Blueprints are the visual language of construction. They serve as the roadmap for building a home, showing everything from the layout of rooms to the details of structural supports, plumbing lines, electrical systems, and more. Whether you're a builder, project manager, contractor, or homeowner, having a working knowledge of how to read and interpret construction drawings is essential to successfully navigating a residential construction project. Blueprints, also called construction drawings or plans, are technical drawings that communicate detailed information about how a structure should be built. They are created by architects and engineers to guide contractors, inspectors, and tradespeople throughout the building process. Modern blueprints are usually created with CAD or computer-aided design software and are printed on large sheets for use on site. Prevents costly mistakes due to misinterpretation, helps ensure correct placement of walls, doors, and systems, aids in project planning, estimating, and material takeoffs, allows better communication with contractors, inspectors, and clients, ensures code compliance and structural integrity. Blueprints are architectural roadmaps that guide the construction of a home from foundation to finish. Each sheet in a blueprint set serves a distinct purpose and must be interpreted with care to ensure every detail is executed accurately. The title sheet serves as the front cover and roadmap of a blueprint set. It introduces the project at a glance and provides essential administrative, legal, and navigational information. Before any contractor picks up a hammer or runs a wire, this sheet tells them where they are, what they're building, and what rules they must follow. First stop for inspectors, contractors, and plan reviewers. Helps identify missing sheets or outdated versions. Ensures everyone on the build team is working from the same reference point. Supports permit submission and code review. The title sheet is the navigation panel of a construction drawing set. It tells you what you're building, where, under whose authority, and with what standards. While often overlooked, it's one of the most important pages in a blueprint set, because it sets the foundation for all the pages that follow. The site plan shows how the proposed home or structure is positioned on the property in relation to lot boundaries, access points, terrain, and existing site features. It's your macro-level view of the entire lot, and is essential for site development, permitting, and code compliance. Think of it as the Google Maps view of your construction project, except with far more technical detail. Excavation and grading determine cut and fill locations. They guide site leveling before the foundation is poured. Local zoning departments use site plans for permit approval to confirm compliance with land use regulations. The foundation layout ensures the house footprint is positioned exactly where it should be on the lot. Landscaping and drainage ensure the land is shaped to manage water runoff and protect the foundation. Bonus elements you might see on a site plan include trees to be removed or preserved, fencing, pools, decks, patios, retaining walls or slopes, set elevations, and flood zone or special zoning overlays. The site plan bridges the gap between land and structure. It ensures the home is correctly placed, legally compliant, and ready to be serviced by utilities and infrastructure. It's the foundation for excavation, permitting, and the very first steps of physical construction. Exterior walls define the perimeter of the home. Interior walls divide rooms and guide the flow of space. Walls are typically represented by thick, solid lines and may include notes on wall types and wall thickness. Framers build walls, door and window openings, and lay out framing. Electricians place outlets, switches, and lighting fixtures. Plumbers route supply and drain lines for bathrooms and kitchens. HVAC technicians plan duct routes, vent locations, and equipment positioning. Interior designers coordinate furniture placement, finishes, and spatial flow. Inspectors verify code compliance and system spacing and layout. Common floor plan symbols you'll see include a swinging door represented by a curved arc, a window shown by double lines in the wall break, stairs indicated by parallel lines with an arrow, a toilet depicted as an oval with a short line on top, a sink shown as a rectangle with a faucet symbol, and ceiling height marked as CLG 9 feet 0 inches. Everything else, elevations, sections, framing plans, MEP layouts, relates back to the floor plan. They allow builders and designers to visualize space before it exists physically. They minimize errors, improve workflow, and support accurate material ordering. If it's not right on the floor plan, it won't be right in real life. Floor plans are the foundational communication tool of residential construction. They define the home's layout, dimensions, and core functions, and inform every trade working on the job. If you can read and interpret a floor plan accurately, you're already well on your way to managing a successful build. Elevations are flat, two-dimensional views of each exterior side of the home, front, rear, left, and right. Unlike floor plans, which show a top-down view, elevations show what the house looks like from ground level, giving a sense of style, proportion, and height. They are essential for visualizing the exterior appearance, aligning materials and openings, verifying building height and code compliance, and guiding contractors during exterior work. If the floor plan is the blueprint's brain, the elevations are its face. Framers and carpenters align wall heights and install doors and windows at correct elevations. Roofers follow slopes and structural transitions. Exterior finish contractors apply correct materials to proper areas. Architects and designers review aesthetic balance and curb appeal. Inspectors confirm structure meets local height and setback limits. Other key features you might see include material callouts, elevation markers, decorative elements, and architectural details. Why do elevations matter? They provide visual clarity for the entire team. What will the house actually look like when built? Elevations resolve issues like misaligned windows, inconsistent materials, or awkward roof transitions before they happen. They are required for permit approvals, especially in HOA neighborhoods, historic districts, or areas with strict zoning aesthetics. They're the visual handshake between design intent and construction reality. Elevations are the artistic and technical expressions of your home's exterior identity. They show the vertical logic and visual harmony of the house, guiding tradespeople in their execution and giving clients a preview of the finished product. Without them, you'd be building blind to how your home will look from the outside world. Sections are cross-cut views that reveal vertical relationships inside the structure. They show wall assemblies, insulation, and vapor barriers. They also illustrate how the foundation connects to the framing and roof, stair details, ceiling heights, and attic configurations. Sections are critical for builders, especially for understanding material layering and ensuring code compliance. The foundation plan provides details for building the base of the structure. You'll see footings and foundation walls, slabs, piers, pads, crawl spaces or basements. It also includes rebar placement and insulation under slabs, as well as anchor bolt locations. This plan is used for excavation, forming, and pouring concrete. Framing plans show how the bones of the house are built: floor joists, wall studs, and roof supports. What's included? Well, you'll find joist layout and direction trusses, beams and headers, wall framing details, and roof framing and rafter locations. Framers use these plans to ensure structural stability and to prevent framing errors. MEP plans lay out all the systems that make the home functional. Under electrical plans, you'll see outlet, light switch, light fixture, and breaker box locations. Plumbing plans cover water supply and drain lines, venting systems, and fixture locations. HVAC plans include duct runs, vents, air handlers, and thermostat placement. These plans ensure systems don't conflict with structural components and are installed efficiently. Schedules and legends provide reference details for materials and components across the blueprint set. What you'll find includes window and door schedules, which list sizes, types, materials, and quantities. There's also the material finish schedule, specifying wall, floor, and ceiling finishes room by room. Symbol legends explain symbols like switches, outlets, beams, and more. Think of it as a blueprint glossary. Use this to decode symbols and materials. Symbols are simplified graphic icons used on blueprints to represent physical objects, components, or systems in a standardized and efficient way. Since blueprints are scaled and dense with information, these symbols help communicate complex details clearly and quickly. Here are a few common examples. Electrical outlet, a standard electrical wall outlet. Variations include GFCI outlet and 220V outlet, used by electricians to locate outlet installation points. Light switch, a single-pole switch that controls a light or electrical device. Variations include three-way switch, four-way switch, and dimmer switch. The S shows where light switches should be installed and what lights they control. Window, a window opening, including its width and style when cross-referenced with the window schedule. This helps with framing, insulation, and window installation prep. Door indicates the location and direction of a door swing, including double doors and sliding doors. This is essential for layout, traffic flow, and clearances. Common blueprint abbreviations include TIP, which stands for typical. Instead of labeling every identical feature, TIP is used to indicate repetition. AFF stands for above finished floor, describing the vertical height from the top surface of the finished floor to an element. OC means on center, describing the spacing between regularly placed elements, measured from the center of one item to the center of the next. This ensures uniformity and structural integrity in framing and support systems. Symbols are visual shortcuts that help you quickly understand what and where something should be. Abbreviations help condense complex instructions or repeat patterns across the drawing set. Mastering both makes reading construction plans faster, more accurate, and far less overwhelming, especially on busy job sites. Blueprints are scaled representations of real structures, meaning the drawings are shrunk down proportionally to fit on paper while still maintaining accurate dimensions. Because a real house can't fit on a sheet of paper, architects and designers use a scale to translate real-world measurements into smaller, readable drawings. This allows builders and contractors to interpret exact sizes, distances, and proportions on site. A common scale used in residential construction is 1/4 inch equals 1 foot. This means 1/4 inch on the paper equals 1 foot in real life. Other examples include 1/8 inch equals 1 foot for site plans or larger homes, and 1/2 inch equals 1 foot or 1 inch equals 1 foot for detailed drawings or room-specific views. An architect's scale ruler is a triangular measuring tool with multiple scales built in. To use it, first identify the scale noted on the drawing, then match that scale on your ruler. Measure the line or distance on the blueprint using the correct edge of the ruler. Read the measurement directly, it will show the real-world size. For example, if a room wall measures 2 inches on the blueprint at 1/4 inch equals 1 foot scale, the actual wall is 8 feet long. Always double-check the drawing's stated scale before measuring. Use the scale ruler, not a standard ruler, to avoid misreading dimensions. For digital plans, use the built-in scale tool in software like AutoCAD, Bluebeam, or PDF viewers with measurement features. Using the scale properly is a critical skill for interpreting blueprints. It ensures accurate material estimation, correct construction, and proper alignment of components. A small measurement mistake on paper can lead to a big error on site, so measure wisely. Dimensions on blueprints tell you the exact sizes and distances between architectural features, like walls, doors, windows, and fixtures. They're essential for accurate construction, layout, and material estimation. Perimeter dimension strings. These are located along the outer edges of the floor plan. They show total building length and width, wall-to-wall spacing, and placement of doors and windows from the corners or other reference points. Interior dimensions, found inside the rooms or hallways. They indicate room sizes, distances between interior partitions, and fixture locations. These dimensions help you lay out interior framing and ensure that every space is built to design. How to read them. Dimensions are usually shown in feet and inches, like 12 feet 6 inches. Start by identifying the exterior dimensions, then work your way inward to determine room sizes, understand wall thicknesses, and identify ceiling height changes or floor-level transitions. Interior walls are often 4 or 6 inches thick. These are included in the total space dimensions. Pro tips: watch for overall dimensions versus partial dimensions. They may not add up unless wall thicknesses and openings are considered. Use dimension lines with arrows or tick marks. They point to what's being measured. Dashed lines often indicate features above or below the cut plane. Understanding how to read and interpret dimensions ensures your framing, finishes, and systems are built exactly as intended. Start from the outside, verify distances, and check interior layouts to make sure every square foot of your project is on point. Blueprint sets are made up of multiple sheets, each focusing on a specific part of the build, like floor plans, elevations, framing, or electrical layouts. To understand how these pieces connect, you'll need to cross-reference between drawings using callouts and detail markers. Detail callouts. These are circular or rectangular symbols with text like A2/8. A 2 equals detail name or number. 8 equals sheet number where the detail is located. This tells you exactly where to find a close-up drawing or technical clarification. Example: a wall section on a floor plan might say B4/10. Flip to sheet 10, detail B4 to see how that wall is built from the foundation to the roof. How sheets reference each other. Elevations reference floor plans. Show how door and window placements line up with exterior finishes. Framing plans reference foundation plans. Show how floor joists align with footing locations. Sections reference elevations or floor plans. Provide vertical construction details of walls, stairs, or roofs. MEP drawings reference floor plans. Indicate the locations of outlets, ducts, and pipes relative to the building layout. These connections keep the entire construction team aligned and prevent costly errors. Why cross-referencing matters: ensures design intent is maintained across every trade, helps contractors and inspectors quickly locate details for execution or verification, saves time and reduces confusion by linking related drawings together, clarifies areas that require special construction. Cross-referencing is like using hyperlinks in a blueprint set. It helps you navigate seamlessly between drawings to fully understand how the home is constructed. Whether you're double-checking a window detail or verifying how a beam is supported, smart navigation ensures accuracy and consistency throughout the build. Grab a sample floor plan and follow these tasks to build your blueprint reading skills. Locate and measure the kitchen dimensions. Find the kitchen area labeled on the floor plan. Use the dimension strings or a scale ruler to determine the length and width of the kitchen. Record the dimensions in feet and inches. Find the front door and note its width. Locate the main entrance on the floor plan. Identify the door swing symbol and check the nearby dimension callout or door schedule. Note the width of the door. Look for any side lights or double door configurations if applicable. Spot all electrical outlets in the living room. Find the living room on the floor plan. Identify all outlet symbols. Count and mark their locations on each wall. Consider whether the spacing follows electrical code. Find the span of a roof beam in a cross-section. Flip to the cross-section drawing that includes a roof beam. Locate the beam symbol and identify its span length. Use the dimension lines or the drawing scale to measure the span accurately. Look for notes on beam material, size, and structural supports. Bonus tip: keep a notebook to record your answers and note any questions you have about how components relate across different sheets. This habit will sharpen your ability to navigate, interpret, and verify drawings like a pro. Blueprints are more than just drawings. They're the universal language of construction. Learning to read them fluently gives you a powerful advantage on any project. By understanding a complete blueprint set, you can avoid costly miscommunication between trades and team members, anticipate construction challenges before they arise, improve build quality through precision and clarity, stay on budget and meet your schedule with fewer surprises. Whether you're a builder, project manager, or a future homeowner overseeing your dream project, the ability to interpret blueprints gives you the insight and confidence to make informed decisions at every stage. On a job site, knowledge is power, and blueprint literacy is your key to control.